Hello, my name is Ali Ifat. Today I will explain to you about this infographic. This infographic introduces PLGA/HA composite as a promising polymeric biomaterial for cartilage tissue regeneration. Cartilage has limited healing ability, so tissue engineering use scaffolding like PLGA/HA to support regeneration. PLGA is biocompatible, FDA-approved synthetic polymer, while HA enhance strength and bioactivity. Together, they form a porous scaffolding that supports cells grow, mimic cartilage load-bearing properties, and safely degrade in 6 to 12 months. Its structure promotes nutrient flow and natural metabolism for byproduct. Preclinical data show strong potential making PLGA as a HA ideal for cartilage repairing. For further understanding, I provide the next video for you to easier to understand. Thank you.
Cartilage is a specialized connective tissue that lines our joints. It acts as a cushion and allows smooth movement. But one big issue is that cartilage is avascular, meaning it has no blood supply. Because of that, when it gets damaged, either from injury or aging, it doesn't heal easily. That's why researchers and biomedical engineers have turned to tissue engineering. This field combines cells, scaffolds, and biological signals to regenerate tissues like cartilage. And for tissue engineering to work, the scaffold must meet certain criteria. It should support the growth of cells like chondrocytes or stem cells, mimic the structure and mechanical strength of real cartilage, and degrade safely over time, ideally within 6 to 12 months. Introducing the PLGA/HA composite scaffold. So, what scaffold do I recommend? The answer is the PLGA/HA composite scaffold. PLGA is a synthetic copolymer made by combining lactic acid and glycolic acid. It's already FDA approved, making it a safe and biocompatible material. On its own, it's a great option. But when you combine it with hydroxyapatite, or HA, which is a mineral naturally found in human bone, you get something even better. This combination results in a bioactive and mechanically strong scaffold that supports cartilage regeneration. It's designed to help cells grow and guide the regeneration process, much like a temporary framework that dissolves as new tissue forms. Structure and properties of PLGA/HA. Let's take a closer look at the structure and properties of the PLGA/HA scaffold. Biocompatibility. It's very safe for the body and promotes cell attachment. The body naturally metabolizes the degradation products, lactic acid and glycolic acid, into carbon dioxide and water. Mechanical strength. Thanks to hydroxyapatite, the scaffold can withstand compressive forces, making it suitable for load-bearing applications like joints. Controlled degradation. The material degrades within 6 to 12 months, which matches the time frame needed for new cartilage to form. We can even adjust the degradation rate by modifying the ratio of lactic to glycolic acid. Porosity. The scaffold is porous, allowing nutrients and oxygen to pass through, which is essential for cells to survive, multiply, and form tissue. Non-toxic byproducts. As mentioned earlier, the breakdown products are naturally removed by the body, so they don't cause harm. Why it's ideal for cartilage regeneration now? Why is this composite scaffold ideal for cartilage regeneration? First, it mimics the mechanical behavior of cartilage, allowing it to handle pressure and movement in joints. Second, it supports the growth of chondrocytes and stem cells, which are responsible for creating new cartilage. Third, it biodegrades safely, meaning it disappears once its job is done, without needing to be surgically removed. Fourth, it has shown great potential in preclinical studies, proving its effectiveness in lab settings and animal models. That's a huge step toward future clinical applications. Part 5. Summary table of key criteria. In my infographic, I included a summary table that compares the PLGA/HA composite against key tissue engineering criteria. Criteria: PLGA/HA composite biocompatibility excellent, FDA approved, mechanical strength high, load-bearing degradation 6 to 12 months, porosity supports cell growth, clinical relevance extensively researched. As you can see, the PLGA/HA composite performs strongly in all areas. It meets clinical, mechanical, and biological requirements, making it one of the most suitable options for cartilage scaffold development.